The predominant visual representation of functions that students encounter is the Cartesian graph. This is a powerful representation, but it's static. The independent and dependent variables are implied rather than shown. Not surprisingly, students tend to focus on the shape of the graph rather than the motion of the variables. They don't attend to the way in which the shape is a consequence of the relative motion of the two variables. To promote students' ability to visualize a function as a rule that connects two moving variables, we're going to introduce a representation known as a dynagraph. A dynagraph has two horizontal axes, with the independent variable on the top axis and the dependent variable on the bottom axis. This representation was first pioneered and the term dynagraph coined by Paul Goldenberg and his colleagues at EDC. You can see the dynagraphs that I'm about to show you on our Sign of the Times blog post. A link to this post is included below the video. So here's our web sketchpad model, and this first one displays 8 dynagraphs across its 2 pages. For each dynagraph, you can either drag the input marker or press the Animate button. As students vary the independent variable, ask them to pay attention to the behavior of the dependent variable. Notice that there are no numbers provided, so students must stay focused on the visual behavior of the functions. Encourage them to describe the behavior in terms of position, movement, and symmetry. One of these 8 functions has an asymptote. How is this represented in the behavior of its dynagraph? Function H exhibits rather amusing behavior when input C is dragged. What function might this be? And which dynagraph represents a trigonometric function? If you'd like to see the actual functions represented by the dynagraphs, press the Show Functions button. In this next model, you and your students get to choose your own functions and view them in dynagraph form. Just double-tap f of x and enter a new function. You can decide whether to hide this function, as well as the numbers and tick marks on the number line, or keep them visible. To hide everything, just press this button. And now, to animate the dynagraph, press Vary X. Page 2 of this web sketchpad model is almost the same, but now the segment connecting x and f of x is traced when the dynagraph is set in motion. In this final dynagraph model, students move between a dynagraph and its Cartesian counterpart. The web sketchpad model shows a dynagraph of a function f of x. And as before, you can change the function by double-tapping it and entering a new function. When you're ready, press Vary X and set the dynagraph in motion. Now, press Show Connector to view a line connecting x to f of x. To continue, press the Cartesian button. And watch, the dynagraph transforms itself, with the parallel axes becoming perpendicular and the connector bending to form a right angle. And there you have it. Your dynagraph has morphed into the familiar Cartesian representation. Stop the motion of x and f of x, tap the Trace widget, and now tap the point at x, f of x, so that this point will get traced. Now, press Vary X again to view the path of the point. You can use the Trace widget to erase the traces.